Hello and welcome to the first video in this tutorial series for Dynamics for SpaceClaim. This series will be covering features that can sometimes be hard to find due to the simplicity of the user interface. Such features include loading trajectories, wires, stability analysis, mechanical interference and much more. And today we'll be looking at loads between structural members. A difficult problem engineers often struggle with is to obtain information about the structural loads that their design will be subjected to. Clearly this is crucial information when structural integrity and function is important. And in this video I will demonstrate how we can solve that problem using Dynamics for SpaceClaim. Here we have a simple model of a lifting device. The setup of this scene is almost complete, but there's one thing missing still. As you can see, the vertical boom is not attached to the bottom frame. There are different ways we can go about fixing this, and one is to merge the two. If we use Color by Bodies tool, we can clearly see that the parts are indeed two separate entities. Another way is to interconnect the members with a joint. Here we use a lock joint, which by default locks all degrees of freedom in the connection. We will also use this joint as a probe measuring the loads that the joint is subjected to. Let's say that we're interested in measuring the torque about the lock joint's C-axis. In order to isolate that particular load in our measurement, we need to drastically reduce the damping and stiffness parameters of the other degrees of freedom. This filters out all loads except the torque we set out to investigate. Finally, we stabilize the overall connection with a hinge joint, which complements the probing lock joint without interfering with the measurement. Now let's have a look at the torque that passed through the joint. If we open up the plot tool, we can find data such as forces, velocities, positions of rigid bodies and so on. But right now we're only interested in the torque that the joint has been subjected to. So let's use the torque magnitude measured by the joint. The data appears immediately and can be inspected directly in this viewer. If we zoom into some extreme values, we can make some basic assumptions about the model just analyzing the data. But if we want to make some more in-depth analysis, such as a rain flow counting for instance, we can of course export this data to a CSV file and import it into external software. Note that the entire load history is recorded, and this is a golden nugget when designing against fatigue failure, which is the single most common cause of mechanical failure in modern engineering applications. If you like this video and want to learn more about Dynamics for SpaceClaim, be sure to check out our tutorial series at YouTube. Thanks for watching.